Okay, in this video I'm going to show you the p-value approach for hypothesis test. Okay, and this is really using our calculator. The basic idea is going to be, instead of comparing z-values, so instead of taking the test statistic for your z-value and comparing it to a z sub alpha or t sub alpha value, what you're going to do is you're going to compare the probability of a type 1 error, alpha, to the probability of our test statistic being less than, greater than on our curve. Okay, so again, instead of comparing a z or a t score, you're going to basically compare probabilities. Okay, so it's very similar to the other process in our calculator. What we're going to do is I'm going to look at example 6 from the packet. We already did this by hand using our test statistic, comparing that negative 4.04 to our rejection region. Okay, now what we're going to look at is how do we do this in our calculator. Well, what we do is we press stat and then go over to test. Okay, and we have to know what kind of test we're doing here. So the knowledge base still has to be the same. Okay, well, notice again, in this one we were given sigma was 3.1, so we're doing a z-test. Okay, and it's a z-test using mu, not the proportion, okay, not p. So it's the very first option in our calculator is z-test, so that's what we're going to use. Okay, and then we have the statistics. Our mu is 75. Our sigma is 3.1. Our x bar from our sample was 73.6. And then our sample size was 80. Okay, so n is 80. Okay, then the last step here is we have to look at our mu. And what is mu? Is it not equal to mu sub naught or not equal to 75? Is mu less than 75 or mu greater than 75? Okay, well, we're trying to say mu not equal to 75. So that's the very first option there, mu not equal to 75. Okay, so if we calculate that, okay, our z-test gives us a z-score of negative 4.039. Well, notice that's the same thing we got by hand. Okay, so the z-score that our calculator gives us, that's our test statistic. Okay, and what we did before was we compared that to the rejection region, and we ended up rejecting HO, and then that meant that we rejected the claim. Well, now they give us another value here, p, and this is what the p-value approach is. Now, the downside to this approach is that do not confuse this p with the population proportion or percentage. Okay, this p is a probability. So 5.36 e minus 5 means you have four decimal you have a decimal point and then 4 zeros and then a 5.36. Okay, so what that's telling us is if we found the probability that z was less than negative 4.04, well, negative 4.04 z-score was over here. The probability of being less than that, negative 4.04, is 0.0000536. Okay, so notice that that p-value is less than alpha. Okay, so 0.0000536 is less than 0.05. Okay, so when p is less than alpha, we reject HO. Okay, so that's another way to get to our decision of rejecting HO. And then the conclusion is still the same. Okay, so again, rather than find our negative 1.96 and positive 1.96, they came from alpha's 0.05. Now what we're saying is don't look up the negative 1.96 on our table. Look up the probability of our z-score, the probability that z is less than negative 4.04 in this case. Okay, so you still have to do some work, but some people prefer the p-value approach. The advantage of the p-value approach is that it allows you to set your alpha value at different values. Okay, so we see that our probability is a very small number. So even if that was alpha was 0.01 or 0.001, we would still reject HO because that p-value is so small. Okay, so that's the advantage of using the p-value approach, is it allows you to really let your alpha be different values, and you know right away if you're going to reject or fail to reject HO based on that. Okay, so rather than saying, okay, what if alpha was 0.01? Well, then let's go, and what will 0.01 give us down here for the z-scores, and then compare negative 4.04 to those z-scores and see if you're in the rejection region. So some people prefer this approach. Now notice what I wrote down for the calculator steps. I wrote down the test that I used. Okay, I used the z-test, and then I put in the mu sub naught is 75, and again that corresponds to HO. Okay, the HO and mu sub 0 or mu naught is your null hypotheses. Okay, and then I put in all the other values, and the p equals 0.000536. That is the p-value from your calculator answer. Okay, I'll do just a couple more of these just to go through the steps. Okay, the next one was that mu is greater than 1030 or 1030, and this one we used the t-distribution. Okay, so here in our calculator we're going to use, instead of a z-test, we're going to use a t-test. So stat test, a t-test. Okay, and we'll enter our values in. Mu 1030, x bar 1033. The sample standard deviation was 5.7. The sample size was 17. And then on this one, the alternate hypothesis was that mu is greater than 1030. So we're trying to say that mu is greater than mu sub naught. Okay, calculate. Okay, and it gives us, in this case, a t-value of 2.17, okay, which is the same as before. Okay, and again, notice I wrote down those sample statistics here on the side. And our p-value was 0.0227. Okay, so I wrote that down here. Okay, and before what we had said, okay, we said that 2.17 was to the left of 2.583. Okay, and again, the advantage to this approach is that we wouldn't have to look up 2.583 in the table. So if we just know that our p-value is 0.02, compare that to 0.01. Well, in this case, our p-value is greater than alpha. Okay, or 0.0227 is greater than 0.01. So what that means is fail to reject HO. Okay, we're basically saying that we're allowing probability from here over to the right, so we're allowing more in there than the 0.01. Okay, which means we have to fail to reject our null hypotheses. Okay, the other thing I want to show you on this is the same thing. Okay, the t-test, except instead of on the bottom, instead of doing calculate, if you do draw, okay, what that does is going to draw our curve for us and shade it. Okay, notice it shades to the right here. Okay, and it gives us an area of 0.0227. Okay, and it gives us the t-value of 2.17, our test statistic. Okay, and again, the only advantage of doing it this way is that nowhere do we have to look up 2.583. Okay, so again, some people see that as a big advantage, some people not a big deal. Now you will see it both ways in the book. They'll say a hypothesis test is performed and a p-value is 0.367. Do you reject HO or fail to reject HO? Okay, so you have to understand what it means. But doing these by hand, you can do them either way. Okay, the last one I'll do is number 8 with you, because this one's a little bit different and it's a little trickier. Okay, this one, we're looking at the probability, your population proportion. okay, is less than 0.37. Okay, so here, when we go to our stat and the test, now, because we have a p-value, a proportion, remember that always uses z. Well, it's not a z-test though, because a z-test, remember, we have a mu, a population mean, and a standard deviation, and a sample mean. Well, we don't want that. We want a one proportion z-test. Okay, and what that is, we have our p sub naught value, which is 0.37. Our x value, now this is where it's tricky in this one. Our x value on this one, x is the number of successes. They don't say we took a sample of size 320 and had 200 successes. They tell us the sample percentage of successes was 0.32. So what we have to do is our x value will be 32% of our sample size. So 0.32, which is p hat, times n, that gives us 102.4. Now I'm going to round that down to 102. So the number of successes was 102. So x is 102. N is our sample size 320. And then p is less than p naught. Okay, and if we calculate that, it'll give us the same kind of thing. Our z-score negative 1.98. Now notice that's a little different than this because we didn't round anything up here. We used the exact value of 0.32. Okay, and that happened because we had a decimal here for x. We can't put a decimal in for x. Okay, we can't actually put that. We'd have to put 102 or 103. Whichever one you put in is going to result in a slightly different z-score here and a slightly different p-value. Okay, but again, notice we have 0.02879 for our p-value, and that is less than alpha's 0.05. So basically saying from here to the left is our 0.0287. Okay, and we're in the rejection region for HO. Okay, so decision is the same. We reject HO, which means there's enough evidence to support the claim. Okay, and again, this is what we put in our calculator. One proportion, that's a z there, a z-test. P naught is 0.37, and then the x we had to find, and that was tricky because of the p hat times n. And there's our p-value there. And again, do not confuse this p-value with the p up here. I know they look exactly the same because of the writing, but this is a population percentage. This is a probability that z is less than negative 1.85. Okay, so that is the p-value approach. You can go through the others, the word problems, and see how they match up with the p-value approach.